Water leakage is a serious problem worldwide. In many cases, water leakage is made worse or caused by constant pressure from the pump. In any municipality, water consumption varies over the course of the day, week and year. These variations cause a problem with constant pump pressure, and they also affect pressure losses in the pipes. When the pressure remains constant at the pump, but the flow changes to meet the varying demand, pressure changes at the critical point. These fluctuations in pressure throughout the system increase stress on the pipes, cause water leakage to rise when there is little demand for the water, and waste energy. A demand-driven distribution system uses flow-dependent pressure instead of constant pressure from the pump, and this creates three main benefits. As water modelling manager Simon Johnson from Thames Water explains, you reduce leakage losses, you reduce wear and tear, which cuts down your maintenance costs and may even allow you to postpone investments in new assets, and you save energy.
This is going to help them with it.
Varying demand and higher flow leads to higher friction losses. If the constant pressure is set according to the friction losses at peak hours, the pressure in the pipe network will increase during quiet periods with less flow. But with flow-dependent pressure from the pump, the pressure stays the same, even at the critical point. The control MPC adapts the pump pressure automatically to compensate for the flow-dependent friction loss. The net result is a reduction in water leakage of up to 20%. Instead of a single large pump running at only one best efficiency point, you can use several smaller pumps, lowering energy consumption. Each of these pumps runs at its optimum efficiency, and only when required. Combining multiple smaller pumps with intelligent pump control reduces up to 20% on energy consumption. A demand-driven distribution system reduces maintenance costs in many ways. A stable pressure means less wear and tear and helps reduce the risk of water hammer and pipe bursts. Eliminating the surplus pressure in the pipeline reduces the overall stress on the pipe itself, and so the number of pipe bursts per year will decrease too. This study conducted by Welsh Water in the UK clearly shows the correlation between nighttime pressure and pipe burst. A 16% reduction in nighttime pressure leads to a 50% reduction in the number of pipe bursts. Demand-driven distribution also reduces water hammer in other ways, for example by the soft build-up function. If pressure drops in your system during a pump stop, the MPC unit will slowly rebuild the pressure. In fact, the system fills up the pipes before it builds pressure. This is much gentler on the pipes, so you achieve fewer pipe bursts, reduced repair cost, extended asset lifetime. Which brings us to our next point. We say that a demand-driven distribution system keeps the water pressure at Mrs. Smith as high as she needs it. But how do we know the pressure at Mrs. Smith? Actually, we don't need to know for sure all the time. We just need to have a pretty accurate idea about the variations in demand over the course of a day, a week, even a year. When do these variations occur? Well, it's usually quite easy to predict. Let's say that here, the maximum demand for water occurs around 5:30 p.m. Then we need to check the pressure at Mrs. Smith. If it's too high, we can turn down the pump a little. We find the minimum demand for water is at 3:30 in the morning. So what's the pressure at Mrs. Smith then? When we know, the pump's performance can be adjusted accordingly, although we must, of course, maintain the minimum pressure required to avoid contamination through leaks into the pipes. The default setup in the demand-driven distribution system will automatically create considerable savings. But if you want to optimize the proportional pressure curve even further, demand at the critical end user can be measured manually with a pressure gauge. with a data logger, or with a radio transmitter that sends back data to the MPC pump controller. Grundfos offers pump types to suit varying demands and scope. To calculate the potential savings, use the online calculator at the grundfos.com site. Demand-driven distribution systems may be based on complex calculations, but they are simple to create. Based on the consumption profile, we select the correct pumps and combine them with MPC controls. Then you are well on your way to less water leakage, lower energy consumption, lower maintenance costs. Demand-driven distribution is based on proven technology used in more than 50,000 installations worldwide. We simply use it in new ways.